Today's video, well, it's just basic what if. What if you go over to your appliance, whatever it is, and you turn it on and it goes on. But the next time you go to turn it on, well, it doesn't go on. Now, what do you do? So let's just take a look at some of the things that I have. And I've got my multimeter, a piece of wire, receptacle, couple of non-contact testers, and a receptacle tester. What should you use? What path do you take? How do you figure it out? Let's go right now. Okay, so let's start off with this receptacle right here. Now this receptacle will only be seen mainly in North America. Some other country use 120 volt receptacles, but they won't look like this, and some will. But this is what we use in North America, and for the most part you're going to have a copper colored side on this side, and on this side you're going to have silver screws. And this is your ground, this is your neutral, this is your hot on this side. So in North America, since the 80s, everything's had to be polarized, which means that everything is directional. So you have the long slot on a receptacle, which is your neutral, and the smaller slot, which is your hot wire, and it corresponds to this side. Now when you look at this side right here, both these plugs are energized when you attach your wires to either side and your ground down below. But you can actually break this tab right here. There's a tab right here. You can just twist off with a pair of needle nose, and it'll make two independent sockets 15 amps each. And you'll see that most likely in places like your kitchen, where you have, you know, plug a microwave in here and a coffee pot in here at the same time and not blow a fuse. Now when we get to the wiring, well, we're in North America, and you've got white neutral, black, which is hot, and your ground, the copper wire. Now in some countries it's brown and blue because they don't use the same electrical voltage we do. They're using between 220 and 240, and in North America we're using between 110 and 120. So you plug something in and it doesn't work, what do? Is it the receptacle, or is it your particular appliance that you plugged in? Now most logic would be, okay, so you plug it in here and nothing happens. Well, you go around to another plug, and if it works in the other plug, well, you know it's the plug, right? But now you have to go back to the plug and figure out, okay, so why isn't this working? Well, we're going to go over a couple of tools here that some people have, and these are non-contact testers. And to tell you the truth, I never recommend any of these to anybody who isn't experienced in electrical, because they will lead you astray, and I don't like them for recommending to people who have no knowledge of electrical. So I stay away from these. But I am going to demonstrate these to you to show you how unreliable these are. The only thing that I recommend that you use is a meter or one of these, a receptacle tester. So let's start on the testing here, and I'll show you what I mean when it comes down to troubleshooting an electrical circuit where you tried to plug something in here and it didn't work, but it worked on another receptacle. So where's the problem in here, right? Let's start testing. Okay, so you're looking at my power bar down there, and it's very similar to this. And we're going to start off with the non-contact tester, and it's the Milwaukee tester, and it's good from 50 to 1000 volts. And all you do is you place it close, and you can see the red light lighting up. This is on the neutral, this is the hot wire. And you can go over to the other ones, and it works fantastic, right? Okay, now that's from 50 volts. It'll fire off on 50 volts. And what does that tell you? That tells you that that circuit could be 50 volts, or it could be higher. But you know what, when it comes down to it, yeah, it doesn't tell you exactly what the voltage is now, does it? So now we're going to go on to the Fluke, and the Fluke is sensitive from 90 to 600 volts AC. So you just hold it close, and this one here will glow blue when it recognizes voltage, and go red when it identifies the hot. And that's very simple, right? Seems very reliable, but nah, I don't like it. I don't like it at all. So I'm going to show you exactly why. Okay, we're going to start off with the Milwaukee this time. You can see it's lit up here, which is the identifier. And if I just go to any type of like an extension cord where my light's plugged in, or if I go to the power plug that's powered the power bar in, and you can see this light up here. Look what happens here. Absolutely nothing. It doesn't work. Now, I will tell you something. It works a lot better on a regular receptacle, and I'm going to explain to you why. But if you go around to these, you will think that the circuit's dead. You get a little bit of a beep there. So now let's move on to the Fluke, and let's just see what this does. I mean, it's not doing nothing. It's not lighting up. It's not doing nothing, right? I come over here. Yeah, it'll light up. Right? It'll light up on the cord. But it will not light up here. And I will tell you something. I've ran into this before. And what it is the depth of the terminals inside is not good enough for the tester itself. If you're right on the side of a wire, on either side, or on some of these receptacles, the way they're actually manufactured is fine, it'll work. But on this type of unit here, it will not work, and I've run across that so many times. On the outside of a wire, sure, no problem. And that's why I don't recommend this for beginners, because they may go to this and say, oh, well, that circuit's not alive. Well, actually it is. And if we just go to our multimeter here, and this is what I like about a multimeter. And the multimeter will actually verify. Now it doesn't matter what socket you put it in, it will work on either way. So you can see there, can you see that there? That is 122.7. Okay, so even if I just reverse them, let's see what happens. 122, well, it was 0.7, 0.8, right? So that way there, you can verify whether you have voltage or not. Because, and you can see how much voltage you have. So what should you expect? So when you go from, say, the hot wire, which is the smaller post, and you go to your ground, you're going to see 122.8. Now you go from your neutral to your ground, you should see 0. And that's the way it's supposed to be. And that's how you can tell whether your circuit is actually intact and whether you have the right voltage. Not by using one of these. These are just used for verifying whether you have power or not. And you have to know, you know, a lot about electricity before you can actually start using one of these, and they'll be reliable for you, but only if you're experienced. Now you got one of these, and this is just a regular, well, receptacle checker. Now, all it's going to do is do the exact same thing I just did with the meter. Verify that all the wiring is correct. So, the whole idea is you're going to get these two lights light up and not this one. So let's plug it in and see what happens. You get these two lit up, but not this one. And if you look at the guide here, there is a little guide. And I'll see if I can zoom it in for you there. And as you can see, it's upside down. So let's turn that right side up so you can read it. So there it is there. Now when they say the word open, that means that it's disconnected. There's a break in the wire. So you can see how at the bottom, you got the two yellow lights, and the red light was not lit up. And you could see the other ones, which is the hot wire, you know, whether it's reversed with the neutral, or the hot wire and the ground is reversed, or it's an open on the hot or open on the neutral. or open on the ground. These are very inexpensive units here. These are like, I would say, under $10, and they pretty much verify everything. Now, if you want to get yourself a multimeter, well, I'll tell you something. This is my go-to multimeter, the Fluke, and that particular model there I find is the easiest for most beginners. And if you take a look at the dial there, you'll see on the left, you just turn it to the left, and that will automatically detect voltage for AC or DC as soon as you attach it. And that's a bonus right there. You don't have to worry about getting on the wrong scale. It's a very basic meter, and it's a reliable meter. So when you're thinking about why doesn't your circuit actually work, well, there could be many items, and I'd just like to show you exactly here. In my experience, I've never found a faulty receptacle. I have found loose wires, improperly placed wires, or when you put the tester on here and you're not seeing at least 117 to 122 volts, well, there's a wiring problem downstream. Not going to be this, it's downstream. And in only one situation have I run across that, and I went down and I found an octagon box on the ceiling, and I lowered the plate down below, and what fell off was a MAR connector, the connector that joined the wires together, and I was getting about 42 volts out of this, and I knew there was something wrong. So all it was actually was loose wiring, which can be very dangerous, and rectified the problem, and that was it. But 9 times out of 10, this is not going to be your problem. This is not going to be what's causing the voltage drop, or the reduction of voltage, or no voltage. First thing a lot of people will do, if they plug in their light and the light doesn't work, they'll change a light bulb. And if you change the light bulb and you go over to another socket and it works, well, you know it's here, right? And then they start going downstairs, you know, turning breakers off and on to see if there's a breaker that's been tripped. And if it hasn't been tripped, well, you got a little bit more investigating to do. And I always recommend to people who are not very knowledgeable about electricity is find yourself a licensed electrician. And you will find it's very expensive to hire an electrician, but overall, it's the lowest cost that you're ever going to run into for getting something done and hiring somebody, because the liability of hiring your brother-in-law to do something that burns down your house, well, that ain't going to work so good for you, right? So I'm saying that a good licensed electrician is the cheapest insurance that you can buy of getting something done right. Thanks for joining me here today. Come back again. If you haven't seen this channel before, you're welcome to subscribe. Cheers.